Good afternoon, distinguished colleagues and delegates to this training. Today is the second day of the Mastering Blockchain training of the Institute of Continuing Legal Education. And it's my pleasure to welcome you today. My name is Tobenna Erojikwe, and I'm chairman of the board of Institute of Continuing Legal Education of the MBA. Today's session is titled Blockchain Architecture and Components, Legal Implications of Blockchain. The facilitator for today is Olubukola Ogunshaki. Buki. Buki is the principal and head Satoshi thinker at BDO Solicitors. She's an emerging tech lawyer, primarily working with clients in emerging technology areas such as NFTs, metaverse, crypto, blockchain, artificial intelligence, as well as cybersecurity and data privacy. Book is highly sought after by her clients due to her 20 years experience in strategy and project management. She's also currently a Web3 legal consultant with Interstellar Inc. and volunteers as Director of Strategy at E4E. Buki holds a bachelor's degree in law from Obafemi Awolowo University, Ile-Ife, Nigeria, and an MSc in project management from St. Mary's University of Minnesota, SMU. She also holds an NFT talent certificate from Frankfurt School of Finance and Management. She's a smart contract research fellow and a Kleros Decentralized Justice Fellow. Book is also a certified NFT expert from the Blockchain Council and a certified international privacy professional, Europe, CIPPE. She's a member of the Nigerian Bar Association, the International Bar Association of Privacy Professionals, the International Association of Privacy Professionals, the Blockchain Nigeria User Group, and more. She's married with 5 children. It is my pleasure this afternoon to welcome Buki. Buki, the floor is yours.
Thank you so much, Amir Buchir. It's an honor to be here. Thank you so much for putting this together. I hope I am audible and everyone can hear me. Good afternoon, good evening, good morning, wherever it is you're logged in from. Thank you so much again, our chairman, for putting this together. Thank you so much to the team at the NBA ICLE. I'd like to thank my fellow panelists as well, who may be in the room. And I'd also like to thank the attendees for logging in. So thank you so much for that introduction. My name is Buki, and because we do not have so much time, I'm going to go ahead and share my slide, and we can start with the session. Okay. Okay, I hope you can all see my screen.
Yes, we can. Thanks.
All right, awesome. So today we're going to be speaking about blockchain architecture and components. Davidson had taken us in a session yesterday, and just like he said, I would also advise each and every one of us not to miss any of the sessions because blockchain is quite intricate. I won't want to use the word, it could be complex if you're not careful, but it's a little intricate. So each of the sessions is very essential so that you're able to understand the entire gamut of blockchain. So today we're looking at the architecture, and I wanted to start by looking at a building because we're speaking about blockchain architecture. So let's look at architecture in itself. So if we take a look at this, this is the Museum of the Future in Dubai. And we can see just from looking at the image that it looks quite complex. And it's just the same thing with blockchain. There are many components that are coming together, but at the end of the day, you have a robust structure that doesn't even look as complicated as the back end or the inner components. So that's how it's supposed to be for us while we're on this training. The components may look complex, but at the end of the day, you're going to have this beautiful structure that doesn't look as complex. It looks quite simple. It does look complicated, but it looks very beautiful. So that's what we're going to be doing today. The first thing I'd like us to look at is the network. So we're typically used to centralized structures. And then we now came about Web 2, which brought about the distributed structures. So centralized, but distributed, more distributed than it was previously. And then we're now going into the decentralized network that is more of a peer-to-peer network. So each and every node acts in its own capacity, spread across, the internet. And that's how we should look at the decentralized structure. So that's the way we need to look at blockchain architecture. So today's course outline, we're going to be taking 2 modules and 7 different lessons. The first looks at the architecture and components. So we're going to look at the structure of a block, cryptographic principles in blockchain, smart contracts, Merkle trees. And then we now look at the legal implications of the blockchain and look at the enforceability of smart contracts, digital signatures, identity verification, and then data privacy on the blockchain. Obviously, it's a lot of information to pack into one session, but if we can touch the basics, there's a lot of material in the slides. I put some links in there so we're able to further study on our own time, but at least you have the main crux of it. So the first is the deep dive into the structure of a block. So here we have a block, which evidently is just a cube, but then we're going to look at what the structure is. The first thing we need to understand going into blockchain is what hashing is. So hashing takes plain text. You use a program to convert it into hypertext or hashed text. Okay, so you use plain English, enter it into a system, and then it comes out with this hashed text. So we're going to look at an example. I have the SHA-256 generator here, which is basically a mathematical software that changes plain text into hashed text. So we're going to take an example, and I'm going to go with the word hello. So you enter your plain text into the generator, and then you generate. And then it comes out with the hashed text, which we're going to copy here. We can see the numbers on the screen. If you're not seeing my screen at any point in time, please just let me know. So we're going to paste that in here. And this is the hashed text for hello. So we're going to go back to our SHA-256 generator. And then we're going to add an exclamation mark. And then generate. And we can see that the hashed text that comes from the is quite different. So I'm going to paste it next to the other one so we can see. So the first one is hello, and the second hash text is hello exclamation mark. We can see that it is very different, even though the only difference is the exclamation mark. So we're going to take that again because we need to understand the concept of hashing. It's very important to the blockchain. So let's take Bright. generate. Now we take our hash text. So this is what bright looks like. And then we go back. And let's add a full stop this time, just a full stop. And we generate. So we can see that even though it's just a full stop that we added to the plain text, it is quite different. So we take this back here. So we can see hello, hello with an exclamation mark, bright, and then bright with an exclamation mark. So it's not likely that anyone will be able to guess what hello with an exclamation mark is. What this tells us is that once you hash plain text, it secures that information. And it's not likely that anyone else is able to reform that information or reproduce that information. And so that is what hashing is when we're speaking in blockchain terms. Everyone will be sent the slides at the end of the seminar, so you can cross-check, with the links that are placed at the bottom left side of the screens. So usually it's a 56 bits or 64 hexadecimal characters or 43 alphanumeric characters or 32 bytes that usually come from the SHA-256 generator. So it's 256 bits. That's why it's called 256. And then SHA because it's secure hashing algorithm. So this is very important to what we're going to learn next because the hashing is part of the blockchain architecture. So now I'm going to explain what the blockchain is in terms of data storage. So the blockchain I usually liken to a Microsoft Excel spreadsheet. You have this information of transactions. Transactions usually take place, a new block is created between every 10 minutes. Let's just say every 10 minutes. Within the 10 minutes time frame, every single transaction that takes place, say on the Bitcoin network, is recorded in this Microsoft Excel spreadsheet. Now, once that 10 minutes is up, every single part of that Excel spreadsheet makes a page, like in a book. So for instance, I have a book here to the right of the screen. All your transactions for 10 minutes is on, let's say, page 1. Once the 10 minutes is up, we start a new block, which obviously we'll explain, but I just want to use the book formula to explain to us. So after 10 minutes, the next page starts up and new transactions are entered into this next page. But the thing about the blockchain is that the pages are connected together. So it's just like a book that is bound together. So after page 1 comes page 2, after page 2, 3, we know how that rolls with a book. So they're all connected together. And that's why the blockchain is also referred to as a distributed ledger technology. The ledger is what I just explained, meaning that all the transactions and all the data is entered into this system. It's just that in this case, it's a digital system. And then they're bound together in the form of pages or in, just the way we say it in blockchain, in the form of blocks. It is distributed because every single person in the node has access to this information. So it's decentralized, distributed. All the nodes are connected, to the pairs. And that's why some are more comfortable with calling the blockchain a distributed ledger technology. But blockchain is not the only type of distributed ledger technology, but it is a distributed ledger technology. So that's for the ledger system, so that we understand how data is stored. So now we're going to go back to our block. And this is what the block looks like. So the data is embedded in the block. And then you have your hash. Remember, we looked at what the hash, how the hash system works. So all the transactions are hashed together. And then that hash output is the first information on the next block. And that's what forms the chain. So every single data in the first block is hashed together to create a hashed text. And then that hashed text is taken from this first block, and that will be the first information on the second block. And so that creates the security of the blockchain, so that no one is able to really enter in new information into the previous block. Because once you change the information, no matter how little, like we saw, even if it's a full stop, the entire hash is going to change. So you cannot re-replicate a new hash, except you use every single transaction in that particular block. Once you change any information, the hash of the block is going to change. And so we have the data, the hash, which is like a digital fingerprint. So once the block has, once we've looked at all the blocks and I've hashed it together, that serves as a digital fingerprint of that first block. And then that fingerprint is taken to the second block, and then we start the new transactions again. Now, once you finish these transactions of the second block, you hash the hash of the first block, which was the first transaction here, all the other transactions, and then create a new hash that now becomes the first transaction of the third block. And this goes on and on and on, thereby creating what we call a blockchain, which is a chain of blocks. So here we have, Davidson mentioned yesterday about the history. We went into the history of blockchain. It started with Bitcoin and Satoshi Nakamoto, but the underlying technology of Bitcoin is what is now growing. That blockchain technology, where you're able to keep secure data in blocks, hash them together, and create this simple but complex system, is where the blockchain technology comes in, and that's the architecture. So now we're going to go further into a block. Now, this is a sample block. You can see all the information that comes with a block. First of all, you have block number. Davidson talked about the Genesis block yesterday, which was the very first block. This is the hash of the block. So no one can go back and recreate this hash, unfortunately. If you change any information there, the hash will change. So each block has a header and a body. It has a version number, a timestamp, a nonce, which is number used only once. This nonce is the mathematical equation that is solved by the miners. I don't want to confuse us, but in order for you to create a new block, miners come together to try to decipher a mathematical algorithm. So you need a super system to be able to do that. They have GPUs and ASICs and systems that actually try to figure out what the mathematical, solve the mathematical problem, and that becomes the nonce of this particular block. And then we have the Merkle root, which we will look at in a few slides. We have the previous block hash, like we said before, and then we have the transaction data in the block. So I'm just going to show us the Genesis block. So this is Bitcoin block 0, the very first one. We can see all the details are here: the hash, the capacity, distance, the value, we have size, we have the version number, we have the Merkle root, which you can easily copy. You can see, once I highlight here, you can see the Merkle root. There's a difficulty and the nonce, which is a mathematical problem that was solved. We have the size of the data, the bits, the weights. So there's a lot of information and data that comes with the block, and you can access any single block at any point in time by coming to a blockchain explorer. And this also works with other systems as well. The same thing with Ethereum. Bitcoin is one network. We have other networks like Ethereum, Solana. There are many other versions. So we can see that all of this is in the block. So we can now have a better look at how the blockchain works. This is an image that I took from Wu's blockchain revolutionizing in emergency medicine. It's a very, very detailed article, which you can go and take a look at, although it's for medicine, but at least it gives you an overview of how the blockchain works and how it could work in different industries. So with all of this information, you now see how the blockchain is chained together with all of this information that is on there. So it's not just a fancy word. It actually does include a lot of systems in there and architecture that brings it to power. Okay, so the next thing we're going to be looking at is the cryptographic principles in the blockchain. The first is the use of cryptography. And cryptography is the use of two keys. We'll go into that in the next slide. First, it guarantees confidentiality. That's the first principle of using cryptography on the blockchain. So it ensures that participants' data or information is quite secure. Then secondly is integrity. It prevents the influence of external authorities on users. For instance, I talked about you not being able to go back to change the hash. So once that information is in there, you can't deny putting information out on the internet because on the blockchain, because the information there is immutable, is secure, and you're not going to be able to influence that in different ways. And then we have authentication, which is guarding against double spending. Can you still hear me?
Yes, we can.
Okay. All right, authentication safeguard against double spending. Now, let me quickly touch on double spending. What double spending is why the blockchain became extremely popular. Previously, we've had other systems like Bitcoin. However, what happened, some of us might be familiar with Second Life. Second Life had this world that they created, and there were funds that were being spent. They created their own currency. But the issue they had was the issue of double spending. And double spending is, if I have $100 and I'm in a community like Second Life, and I say I'm online, I have this digital money. If I buy something online that is $20, I should have $80 left. But what happened previously was that users on the digital space were able to spend that $20 twice. Who can prevent me from spending my $20 twice? I could go to one platform and buy a pair of shoes there for $20. I could go into another shop and buy something else for $20. And I might be able to claim that I still have $80 left. No one will be able to prove me wrong. So that was the issue with previous versions of digital cash. But with Bitcoin and the blockchain technology, you're not able to spend that money twice because the information is embedded in the system and you're not able to go there to take that information out. Secondly, they guarantee that each block, before a new block is launched, the previous transactions on the other block are all verified. Every single transaction is verified before you move to the next block. So that was able to cure the issue of the double spend, which a lot of digital cash proponents before the Bitcoin were unable to solve. And then we have non-repudiation, which is another cryptographic principle on the blockchain, ensures that no party can deny that it sent or received a message via encryption. Again, a lot of digital fingerprinting, once the data is there, you're not able to change that information. You're not able to deny because there is a digital footprint that is tracked along the blockchain. And then lastly, key management, which is secure communication and protection of data, which is these keys. You need to be able to manage your keys once you're on the blockchain, and we're going to go into that so you'll be able to understand that better. So confidentiality, integrity, authentication, non-repudiation, and key management are the core cryptographic principles in the blockchain. So now we're looking at cryptographic encryption. Now we have two types of encryption. We have symmetric encryption and then asymmetric encryption. We can see at the top of the page here that symmetric uses one key. So the same key that you use to encrypt or open, the same key you will use to decrypt or close. So that's symmetric encryption. Asymmetric encryption is when you use one key to encrypt or open and another key to close or decrypt. So asymmetric has two keys, symmetric has one key. And so this is it here. You have plain text. The encryption takes place with a secret key. You keep that key, and then you use another key, which is another secret key, to decrypt, and then you get your plain text back. So the asymmetric is the use of two different keys, and that is part of the architecture of the blockchain. I put this here again so that we can understand it better. So symmetric, you open and close with one key. Asymmetric gives you double guarantee of security because you are using one key in one part and another key in another part. So two different keys and then one key so that you are able to remember it meticulously. So I decided to give us some examples here of the employment of symmetric encryption. Just like there's some houses that have security keys, the same key you use to open, you use to close, the same with cars, the same key that you use to open, you use to close. So it has that system within it to be able to close and then to be able to open as well. WhatsApp also uses symmetric encryption to scramble messages in transit so that the sender and the receiver possess the same encryption key. But a third party who does not have that key is unable to decrypt the messages. So just the sender and the receiver, but it uses symmetric encryption to decrypt and encrypt the messages. So now we're going to asymmetric encryption example. VPN networks is an example of asymmetric. So you secure your tunnel between the device and the VPN server. So your device has its private key to encrypt the data while the server uses the public key to decrypt the data, and so that data can, get to where it's going, and you have that tunnel between yourself and the VPN server, but it uses asymmetric encryption. And so with cryptocurrencies on the blockchain like Bitcoin, it uses asymmetric cryptography for secure transactions. So each user has a private key for spending their coins and then a public key for receiving payments. So this, for those that already use, those that already have wallets and already use cryptocurrencies, you have your public address, you send your public address to anyone. Anyone that has that public address can send you cryptocurrencies, but you are the only one that has a private key, which should remain secret, to spend the coins that have been received into the wallet. So you can have as many people get your public address or your public key, but the secret key, which is the private key, must be kept to you, which again is part of the downsides of the blockchain, because once you misplace the private keys, then you do not have access anymore to those coins. We have several people all over the world who are trying to retrieve Bitcoin that they had in different laptops and systems that they've not been able to because they misplaced their private keys. So once you misplace the private keys, then you don't have access to the coins. So we have gotten to this part now, which just shows you the blockchain architecture basics. So you have your block, We've looked at the block and the components of the block. Davidson took you all on consensus mechanism yesterday, and then we have talked about the asymmetric keys, which is the double keys that you need. So this creates this security on the blockchain that is, if I can call it, triple-pronged, and makes it definitely more secure. Now, I put this here so that we can understand the aspect that we have talked about right now. It's this little triangle here. So on the blockchain, we have some vertical components, horizontal, and then cross layers as well. The horizontal layers are the network layer, which we've looked at, infrastructure layer, consensus layer, application layers. The vertical, which like I said, we can't deal with everything in 4 days, but you can go ahead and read more about the vertical layers, which is the layer 0, 1, 2, 3. So we have this security layer that we've done. We've done part of the horizontal layer, which is the network layer, consensus, and data. You can learn more about the vertical layers. And then we also have cross chains of bridges on the blockchain as well, but so that you have a holistic view of what the architecture of a blockchain actually looks like. So the next thing we're going to be going into is smart contracts, the definitions and the functionality. So what are smart contracts? In 1994, Nick Szabo, who is a legal scholar and cryptographer, proposed the use of a computer protocol to digitally facilitate or enforce contracts. So it's a self-executing contract, just as mentioned yesterday. An agreement, for instance, between a buyer and a seller, written into lines of code. So we do not need any third party in the middle. It's just user A and user B. They go into a contract together. All the terms and conditions are written into the code, and the code self-executes itself. So it's Turing complete. And that's what a smart contract is. The predetermined conditions must be embedded in the code. So the code and agreements contained exist across distributed, decentralized blockchain networks, and the code controls the execution. So the advantages here are that it's trackable, is irreversible, and once just like we said, once it's stored on the blockchain, you can't really change it. You would have to execute a new contract to counter a previous smart contract. So what we have here is trusted transactions, which is the reason why we find a lot of people rushing towards using smart contracts in the decentralized space. And it can be done anonymously between parties without the need for a central authority or legal system, which is where we have issues with the regulators and central governments who are extremely worried about who monitors these smart contracts. So this is a pictorial example dashboard of Gemini, their chain leaf. So it just says a smart contract is if, and then it's an if and then program. So if I get into a car, an Uber, which we'll look at, if I get into an Uber and I tell it to take me to Palomo and I get down, then 10 USDT will be subtracted from my wallet. So the wallet, in this case, in the case of an autonomous vehicle or an Uber, the wallet of the user would have been connected already, and then they use the smart contract to execute the transaction. And remember that once the transaction is executed, it is embedded in a block of which previous subsequent blocks will come, and then you're able to change that transaction. So if and then program is what a smart contract is. So this is the way traditional transactions work. On the left, we have user one, we have the central authority, which is maybe I buy a pair of shoes, I transfer to your bank account, the bank then sends to the user. That's the traditional way of buying and selling or trading. Whereas in the case of a smart contract, we have user one and user two, and the only middle party there is the computer code that is going to execute the transaction. You can read more at the link. So this is how smart contracts work. So we have the developer who is in the team. For those of us that may be getting into projects, we will have to work with developers who are going to be the ones to embed the terms and conditions in the code, as opposed to the agreements that we would ideally send across as lawyers. The developers embed the code, which if you become a blockchain lawyer, you would have to sit in many meetings with developers, because that predefined contract needs to be as thorough as you can make it. I mean, the reason why we will still have lawyers is because there will always be circumstances that we can't predict that may happen. But generally, where everything goes according to plan, all the predetermined and predefined terms need to go in the contract, or the terms in the smart contract itself. And then you have the event that triggers the execution, and then you go to execution, which contract policy is automatically executed and assets are released to the parties. And then you have settlement, which is where the transaction is settled and all the details are recorded, like we said, on the blockchain. And it keeps going that way. So we have different examples here of circumstances in which smart contracts can be used. It could be used for insurance claims, to renew claim schedules, automatic toll payments. If I drive my car to this toll and my plate number is scanned, then this certain amount can be deducted from my wallet. So everything now is automated. I don't need to stretch my hand out to be just the same way the tags work at the tolls, but instead it's just the smart contracts that are executing payment, the trade itself. You could also use this for fueling, refilling schedules, vehicle maintenance. There's so many examples, but I just wanted to give us an example. Driver's license validation and all whatnot. These can be executed on the blockchain via smart contracts. And then this is how some of the data works. So we have the blockchain at the top, where this is an autonomous vehicle. You get into the autonomous vehicle. There's some people that are already building projects like this, where Uber is using an autonomous vehicle. And I know Dubai has launched a number of autonomous vehicles. So you get into the autonomous vehicle and let it know your destination. So you enter in your destination into the app or whatever software it is that you're using. And then it feeds this into the ledger. Once you get to the location, it deducts the amount from the account. It feeds the information into the ledger. Just like we said, the ledger is part of the blockchain. And then the miners verified transaction. And once the transaction are verified, they're hashed into a blockchain. And then you keep moving like that throughout. So you have these advantages, which is immutability. You're not able to change it. Improved traceability, as opposed to how regulators initially thought the blockchain was primarily used for, was non-traceable. The opposite, in fact, is the case, where you have improved traceability on the blockchain, because once a transaction is carried out, the user is unable to change that information, and so it stays there, which you're able to easily track. Then you also have the decentralization of the data, meaning just like we were able to go to the Blockchain Explorer to view the details of the Genesis block, anybody anywhere in the world can actually have that data. They can download that data on their system. The system is a node in the network, they can download that data. And so it's decentralized, anyone can have access to it. And then we have privacy and security of the data, which we will go into this before the end of this session. And then of course the transparency of the data, which it's public, and so anyone can view that information. Having said that, we did yesterday discuss that there are different types of blockchain. So we have the public blockchain. We also have the private blockchain. So you could actually have create a system where, for instance, a bank wants to have use blockchain for their transaction. They would have to create a private blockchain, and then access controls will be given in that particular environment. So different cadres of people who have access to certain kind of information. So that's private. And then some have a consortium. The consortium is the different players. So maybe 2 banks can come together or 3 banks can come together to create a system. That makes it a consortium. And it could also be hybrid. Hybrid meaning that part of your blockchain infrastructure is public, and then another part is private. So the back end could be private, and then the front-facing part could actually be public. So transparency of data depends on the type of blockchain that you are using in that particular circumstance. So now we're going to go into Merkle trees and their role in data integrity. So a Merkle tree is also known as a binary tree or a hash tree, and is a data structure that is used for summarizing and verifying the integrity of large sets of data. Because of the amount of data that is being stored on the blockchain, it would be difficult to verify and summarize and summarize and not summarize the data that is on there. If we're nitpicking at every single transaction, it's going to take a very long time to verify large sets of data. So the Merkle tree or the binary tree is there to help make that easier. And it was created, patented by Ralph Merkle in 1979, which we can see that it's been a long time that it has been created, but the technique was now brought into the blockchain space. So the term tree is used in computer science to describe a branching out structure, but in this case, the Merkle tree is like an upside down tree as opposed to a tree standing up vertically. So this is what a Merkle tree looks like. You can see that it's an upside down tree. The root is at the top, and then we have the branches and then the leaves. So I try to make this as simple as possible by using 1 to 8 and then 9 to 16 so that we're able to understand it. But for those that deal with the Merkle roots in real life terms, the numbers are quite specific, and they're way more than this. So in this instance, we have the leaves here, which is 1 to 8. We can see that the combination of 1 and 2, when hashed, makes 1, 2. Just to make it easy for us to understand. And then 3, 4 makes 3, 4, 5, 6, 5, 6, 7, 8, 7, 8. And then once we combine these and get into the branches, we can see the numbers are increasing. So the combination would then be 5, 6, 7, 8 at the top. And then here 1, 2, 3, 4. And again, we keep doing that. We add the blocks together to make a combined number. And so we find that here we have different leaves. We have 2 different sets here. In reality, it's usually more than that. But the 2 different sets here, which is 1 to 8 and 9 to 16, make up this Merkle root at the top, which is 1 to 16. So that's the combination, the summary of the transaction. So it's now easy for you to be able to look for transactions. Now, why is this important? This is important for those who are verifying transactions. So for instance, if you wanted to verify a transaction, only few blocks, few leaves, and few branches will be made available to you. And then once the trees, the information is made available to you, you'll be able to determine whether that transaction is part of that particular block or not. Let me give an example. So we go here. So we've taken out some of the transactions. Let's call them transactions. So for instance, if I gave you 1 and 2 here, if I gave you a hash of 1 and 2 here, and I gave you 1 here, you would insert the transaction code that you have into this second box. Once you have 1, if you try to hash using a hash algorithm, that transaction with this one, it will definitely make 1, 2. So that's how you are able to verify that that transaction is actually supposed to be here. But if you put a transaction in here and it's not 2, let's say we try to fit 3 in here. Once you try to hash it, the hash will not come out as 1 and 2. And so there, right there and then, you can tell that that transaction is not verifiable. But if it was 2 that I gave you here, you would be able to easily verify because the hash should be the same. Remember, we've done hash. That was the very first thing that we did. Same thing for if we come here. We can see that 1 and 2 is here, and I have 5, 6, 7, 8. If I add the hash of 1, 2, 5, 6, 7, 8, and I get 1, 2, 3, 4, 5, 1, 2, 3, 4 in this particular box, I would get this hash. But if I add, say, 9, this 9, 10, 11, 12, and I put this here, it will not give this hash number. And so then you're able to alert whoever it is that that transaction is non-verifiable. So a Merkle root is a complex tree system, but is an effective system in that you are able to verify transactions once you have the corresponding hash of another transaction. So the verifiers are now able to more quickly verify transactions as opposed to trying to verify each and every single transaction on that particular block. This makes it much easier. And then you take the hash. If you have only these 2 transactions and you hash it together, you definitely always get the same hash because it's a mathematical formula. It doesn't change, and the hash will always be the same as long as the number of transactions that you are putting in there are the same thing. It will always come out as the same hash number. So this Merkle tree is very important for verifying transactions on the blockchain. Many organizations use it to audit their transactions to make sure that all the transactions that they have in their books or in their system are all verifiable transactions. They can easily make use of the Merkle tree for that. So the Merkle tree ensures data integrity, prevents the manipulation of data. Also, like I said, it helps with the data chunking. Large sets of data, you are able to verify just by having use small blocks or a reduced number of blocks to tell if a transaction is actually verifiable. It uses hashing, just like we have done with the SHA-256 to generate a unique hash value. And like I said, that hash value will always be the same as long as the transactions that you're entering are the same. The tree construction, like I said, it has leaf nodes, parent nodes, which are the branches, and then the single hash at the top, which is the Merkle root. And that is what each block must have. They must have the Merkle root hash in there. So it ensures efficient verification, tamper detection, and then scalability as well. If you have any questions as we're going along, just type it in the chat box. We should be able to take that towards the end of the session. So we're going into smart contracts and their enforceability. What exactly is enforceability of a smart contract? The smart contract is like a regular contract. It has an offer, acceptance, consideration, and then we added the extras, intention to create legal relation, which is a legally binding contract, and then capacity. The terms of agreements are clear and unambiguous, and then so you generally have smart contracts as enforceable in almost every part of the world. And then again, like we said, smart contracts are being used for different things. For example, trade, buying and selling online, and all of that. And so the offer is made. For instance, I want to create my app and I want to transact with someone in India. I can go to specific platforms that offer smart contracts for that. We get into a transaction together. I make an offer, he accepts. We agree on what the consideration will be, what the terms will be. We put all the terms and the conditions in this smart contract, and then it self-executes. So once the person who is the creator or the developer in India, once he's done and he submits it into that particular system, then the money is released into his account, which then begs the question, what then happens when there's a dispute, which I think we might be able to touch on later. There are actually systems where you can actually go in and to dispute resolution systems where you can go in, report your matter, and then dispute is settled by arbitrators on the blockchain as well. So there are a lot of things that are actually going on the blockchain, which we could learn a lot more about later. So we're going to go into digital signatures. Okay, I'll do the questions later. So digital signatures are electronic counterparts of traditional handwritten signatures. They use cryptography to ensure authenticity and integrity of a digital document or message. When you digitally sign a document, you essentially apply a unique electronic stamp. Now, for digital signatures, for us to understand this more properly, on the blockchain, we have different types of assets. So we have, that could be referenced. We have the fully digital assets, and then we have digital assets. So a digital asset is a fully present asset on the blockchain, whereas a digital asset is an asset that has partly physical attributes. So I'll give an example. A number of fashion designers have launched digital assets for fashion, where, for instance, I know Gucci, Hermes, and a number of them, Tiffany and Co., all have digital assets where when you go on the blockchain and you buy, for instance, let's say a pair of Gucci shoes, the physical shoes would also belong to you. So once you buy the digital asset, the physical asset is actually also sent to you as well. So this helps them drive more marketing sales, to have people kitted physically in the shoes, and then for their avatars to also have the shoes digitally. So they're also digital assets as well. So now when we're talking of digital signatures and legal validity, there's still some gray area with regards to if the digital signature covers the physical aspect. But in most parts of the world, once you've signed a document electronically, it does cover whatever terms and conditions have gone along with the document that is attached to the digital signature. So on the blockchain, the digital signature shows that you are the signer. The signature is linked to your private key, which only you have access to. So you're not able to, again, like we mentioned, to deny that you have signed a document when it is actually linked to your private key or your public address then the document hasn't been tampered with. Any changes to the document after signing would invalidate the signature. So digital signatures and their legal validity actually work on the blockchain as well, because electronic signatures are generally acceptable all over the world. So once you sign a document digitally, it does mean that you have consented to the agreement. So for electronic signatures, as a valid means of authenticating electronic documents, we have Section 93 of the Evidence Act, Section 17 of the Cyber Crimes Prohibition and Prevention Act, and 101 of CAMA. So generally, I believe that this is not, there's no bone of contention with electronic signatures. They do carry legal validity for documents. There's no ambiguity under the Nigerian law when it comes to admissibility of e-signatures. Many of the documents that we sign now are actually digitally or electronically signed. And I put this quote here, which says that the law cannot be and is not ignorant of the modern business methods and must not shut its eyes to the mysteries of the computer. And the reason why I put this here is because we've moved now from e-commerce in many instances to meta-commerce. So there are a lot of transactions that are taking place in the metaverse, which is a digital social economy. So there are people that actually in the metaverse have houses, people run their offices in the metaverse, people are signing contracts of sale in the metaverse, there are contracts of employment, there's trade happening in the metaverse. People are buying all sorts of items. They're buying skins, shoes, fashion items. People are buying even physical items from the metaverse. So for instance, you could walk into a Samsung store, for instance, and buy a phone that you can use in the metaverse. And sometimes that phone would also be sent to you physically in the real world. So a lot of transactions are taking place in the metaverse. And so we need to understand these digital signatures and legal validity as well that comes along with transacting meta-commerce, e-commerce. And as a lawyer going into this space, you would need to verify and ensure that all terms and conditions for all of these contracts are actually entered into on the blockchain as well. This also happens for banking. I know many banks are getting into the metaverse as well, opening banking halls. And so all of this is a lot of development in the blockchain space. And so we need to understand that these digital signatures are actually valid and what they carry. So now we're going into identity verification and data privacy on the blockchain. So identity verification on the blockchain is a new method of storing information and storing data. I put here different industries that we're having identity verification so that we can at least speak more about it. For instance, in healthcare, right now, most information is being stored on Web 2 platforms, and Web 2 is the internet as we know it. Once information is being stored on the blockchain, it brings another dimension into play because the blockchain is a space where information is immutable. You are not able to go there and change that information. Also, the information is decentralized. So many parties are able to access that information. There's transparency in the system, and then that brings efficiency in some aspects. But like we understand, that would also bring about some other issues when it comes to transparency. Part of the issues can be solved by selecting the type of blockchain that you use. So for instance, some healthcare organizations choose to have their systems as fully private blockchains, where nobody else, no member of the public is able to access that information. Only parties who have the specific keys that are allocated to them can access the system. It also helps to ensure that once a person accesses information, you can actually track. So every single time a team member accesses private information on a blockchain, you would actually be able to track access controls on the blockchain. And so that is that's something that needs to be balanced. You need to have an expert who understands the system to be able to balance the interests of data privacy on the blockchain and then transparency and efficiency for the organization on another side. I talked a little bit about e-commerce and meta-commerce as well. Social media too is also not exempt. We have, I know recently I heard that TikTok has launched their own cryptocurrency, and so they're going to be able to facilitate transactions via their social media platforms in digital currency, which obviously part of the information is going to be stored on the blockchain. We have smart cities as well. There's banking. A number of the banks are building back-end blockchain systems, and these systems will not be the public will not be privy to these systems until it becomes fully embedded at the back end. And then people will now realize at the front end that many of their backends are now built on the blockchain. There's also supply chain logistics. So for instance, I read, was it yesterday, that the makers of Oreos and some of the popular ice creams in the US are now signing on to blockchain systems to track their supply chain. And this is very useful because you're not able to, so let me give an instance. If I bought a chicken in a supermarket in the US, for instance, and the system is signed onto a blockchain supply system, you would be able to scan the code, the barcode on the chicken, and you'll be able to see the entire supply chain of exactly where that chicken came from. So it will take you from the supermarket to maybe the farm that they got it from, or maybe the importer that they got it from, and then from the importer to whatever country it came from, or whatever farm that it actually came from. All that information would actually be embedded into a code, and once you access that code, you'll be able to see the entire logistics chain of the movement of the chicken. And that is actually embedded into the blockchain. So no one can actually go there and change that. So a number of healthcare organizations and manufacturing organizations who are manufacturing drugs are actually signing on to blockchain systems like that, so that that gets rid of the middle parties who are creating fake medicines and fake drugs, and people are able to actually, be able to walk through that entire supply chain process. There's also trading that is being done online, and every step of the way you are able to verify who the people are. And remember, we talked about non-repudiation, meaning you are not able to deny. So once you put something out there and the information is stored on the blockchain, anybody at any time can trace it back to you, as opposed to what we have nowadays, that people are able to produce items and actually disappear from where they produced it from. And so there's no efficiency in tracking such systems. Financial sectors are also coming on board with all of this identity verification. And in fact, new systems are being created where you will now have a new digital ID created. And that's where actually the world is going, where once you have your digital ID, and that digital ID is embedded into a blockchain system, the person is not going to be able to change that digital ID. The information will follow you forever, basically, unless I know Davidson touched on that yesterday, unless the blockchain is hacked or quantum computing comes into play or some sort. We also have education. And education is a big part in identity verification because, for instance, once universities, there are a number of use cases in education. Once you graduate from a university and your certificate is produced, if that certificate is embedded on the blockchain, you're not going to be able to change that information. For instance, people who say graduated with a 2.2, converting it to a 2.1 in certificate and submitting that certificate somewhere, that's not going to be possible on the blockchain, because once the university has put that information out and stored it on the blockchain as a certificate, then the user is unable to tamper with that information. So it's very important in the education space as well to verify identities of individuals. And many times the documents would actually carry a digital fingerprint. So either a digital ID of the person who owns the certificate or a public address of some sort to link to that particular person's ID. So we find that going into the future, we are going to have a number of these systems tied together where your identity is tied to the documentations that you get or you receive or you put out, so that you're not able to deny. And thereby we find that many people are proposing that this should reduce corruption, because once people's IDs are tied to their documents and they're unable to manipulate that, they would make sure that that information is actually correct. Then we have tourism as well. Tourism is also a major aspect of identity verification. Some countries are actually working on digital passports. Some already have digital passports. Some countries like Estonia and the rest have e-citizenship, where your status as a citizen is actually electronic. And so you'll be able to have a system that gives you a digital ID, and you are able to have your passport details in there. You are able to travel with that particular information. And once your code is scanned, people can tell where you've been. For instance, if you're going for a visa interview, it's not like you're bringing all these massive documents like we're used to. Many of the information will now be embedded digitally. And so they'll be able to have access to that information backend, although we'll talk about that with data privacy as well. We also have property. I didn't put property here. I know that Lagos State has started the EGIS system, and many of the land registries are actually working on digitalizing their registries, where the information of C of O's and land documents are actually embedded on the blockchain. And let me just explain a little bit. So once the C of O will be converted to a token. I don't know if I even mentioned that. Once an asset is stored on the blockchain, it can actually be converted to a digital token. So I'd give an example with a land document and the land registries. What will happen eventually is your C of O for a land will be converted to a digital token in form of an NFT. I know that, I think Davidson touched a little bit on NFTs yesterday. So an NFT is a non-fungible token. A fungible token is a token that is interchangeable. So an example of a fungible token is USDT. USDT is a stable coin which is available on the blockchain. The stable coin, 1 USDT is equal to 1 USDT, no matter where it is that it's sent from. when you come into the physical world, $1 is the same as $1. 1,000 naira is the same as 1,000 naira. It doesn't matter the kind of note that you give me, the value remains the same. So for instance, if I have a 1,000 naira note and I have two 500 naira notes, both 500 naira notes still equal to 1,000 naira. It doesn't matter if I break it into 200. If I give you 5 200 naira notes, is still equal to 1,000. So 1,000 is 1,000. It's still interchangeable. I could tell a malam at the side of the street, maybe I took a bike and I didn't have change, and I want to give the bike driver change. I could tell, somebody selling something at the side of the road, do you have two 500 naira notes? And the guy will say yes, and give me two 500. It's still the same as the 1,000 naira that I gave you. So those are what we call fungible tokens. Each token, they're identical to the next, they're interchangeable, they're exchangeable. But a non-fungible token is a token that is not interchangeable, is different. For instance, I can't give you an Apple laptop and then you give me a handbag in return. They are non-fungible, they're not interchangeable. And so, you just can't exchange the same thing. And for non-fungible tokens, which we call NFTs. NFTs are non-fungible because you can't exchange one for the other. It's not the same. Even when we buy the same exact asset on the blockchain, the value may still be different. So for instance, if I buy a Bored Ape, which is a type of NFT, and Davido buys a Bored Ape, which is the same exact type of NFT, the value of his may be likely higher than mine, because more people may want to pay more for a Bored Ape that was actually owned by a music star, as opposed to one that was owned by a lawyer that they might not know. So even though the assets are even the same, the value still would be different. So it's still non-fungible. And so for land certificates, C of O, certificate of occupancy, and land documents like that, a survey plan or whatever it is, they will be regarded as non-fungible tokens. And so once the C of O is scanned at the land registry, they will convert it to a non-fungible token, an NFT. So once it becomes a digital token, every single transaction that takes place on that NFT is automatically saved into the blockchain. So like all the searches that we go to the lands registry to conduct, all we'll need to do will be to scan a code once we're giving access control to the back end of that NFT, and we'll be able to see the entire history of every single person that has owned that particular token. So going forward into the future, I anticipate that our children and children's grandchildren and generations to come will be accessing their certificate of occupancy via a token, and they'll be able to see all of the history on the back end digitally. So that's just an example. And this ensures that you're able to verify at each point of the stage. And again, just as we talked about the public and the private keys, only those that have the private key will be able to access the NFT or the back end of that particular information. The public-facing information is going to be what is good for public consumption, but anything that comes with the back end and all that will be done with a private key. So these are just some of the examples. HR is the last one. People are going to be able to verify employee records. So you go to a company, you want to be hired. In the future, they would get your maybe public address. And once they access that public address or your digital ID, they're able to view certain information or confirm or verify certain information that you have claimed. So for instance, the educative aspect, your certificates, conferences you've attended, all the CV that you'll be writing, different conferences or things that you have not attended, in the future, things like that to be verifiable on the blockchain. Okay, so now that brings us to data privacy on the blockchain and challenges for data privacy. So there's the issue of when information is transparent, does that contravene data privacy laws? Does that contravene human rights and things? How much of information should be transparent? So we have that issue of transparency versus privacy. And that's what a lot of organizations are currently trying to grapple with, how to manage data privacy on the blockchain. Because we've discussed this previously, that once information is stored on the blockchain, then you are not able to go there and delete it. So then what happens to, for instance, the regulation that states that a user has right to erasure or data deletion? So what happens? I want you to delete my information. I don't want you to have my information again. Or I want to port my information from you and take it somewhere else. How do you handle that on the blockchain when you have embedded that information into a system that cannot forget the information? It will always be there. So a number of people are taking some certain actions. Some are storing their information off-chain. So there's on-chain. On-chain means you're storing the information on the blockchain. And some and off-chain means you're storing that information off the blockchain. So some organizations are actually embedding hashes. So the hash of information is placed on the blockchain, but that information is stored off-chain. So that if you want to access the information, you can click on the link that will take you to the information off-chain, but the information in itself is not stored on the blockchain. So that where a user has now decided that they want that information deleted, is easy to delete off-chain as opposed to it being on-chain. And the on-chain hash could be there, but might not lead to any information in the future. So I think that's another area that can be discussed. You can learn more about that, of how some information is stored. There are actually file storage systems that are on the blockchain, and then there are some file storage systems that are off the blockchain. So depending on the kind of organization and the system that you are building, or the project that is being built, all of that needs to go into the preliminary, data privacy by design at the beginning. These are the questions that you need to ask at the beginning of the project that helps to design the privacy for the organization. And so then there is the issue of private blockchains. So some use private blockchains, like I said earlier, instead of public blockchains, so that those that have information, access to that information, are only certain private entities that are, or members or individuals that are given the private keys to access that data. So some organizations are doing that, especially where it is information that is necessary for the running of the business and all of that. They can actually have that done on a private blockchain. And obviously, there's a lot of regulatory uncertainty about data privacy, partly because some of the solutions for addressing data privacy on the blockchain need to be addressed by somebody that understands how data works on the blockchain. But if the regulators don't understand the way data works on the blockchain, how data is stored, how what kind of infrastructure can be built on the blockchain, then they might not be able to actually regulate appropriately for data on the blockchain. And so that also is an issue. There are certain gaps, there are certain gray areas, and we find that people are taking advantage of the gray areas because regulators haven't gotten to that aspect yet. So part of that also needs to be addressed. Then there are technical limitations as well. Depending on the type of infrastructure that is being built, there are certain limitations that some systems would carry, and if the developers don't have someone who is well versed in data privacy in the meetings with them while they're trying to design and trying to build, they might not understand ways to go around it. So a lot of the meetings that we have with developers, you find out that maybe once we're talking about KYC, how to go about implementing KYC on the blockchain, or this data can't be here, we need to put this data in another format. Some blockchains can actually not handle that capacity. So you can imagine you've already gone, past pilot phase, and then you are realizing that the technical capacity of the particular blockchain that you're building on would not, afford you the full spectrum of the services that you want to offer. So that's why privacy by design is very important. You need to have those meetings at the initial stages before you go far in the project, and then you have to start either compromising your integrity or spending a lot more money trying to improve data privacy or include data privacy on your blockchain project. Now, what are the solutions on the horizon? We have a number of solutions. We have privacy by design, which I mentioned earlier. You start with the privacy from the beginning. You need to have your data privacy impact assessment from the beginning. You need to know where information is coming from, where information is going to, how you can store that information, where you can store that information. All that needs to be discussed in advance so that you are able to avoid some of these mistakes that people have made. Right now, as we know it, there are people that are actually storing information on the blockchain without knowing that they can't actually go and delete that information. They can't move the information because they are building wrongly. And so privacy by design needs to be done from the beginning. You need to, for us lawyers that are part of projects, we need to make sure that we are advising appropriately for those that are starting out projects. For those that are in-house, you are taking part in the meetings with the developers as at the beginning, at the onset, when they are still doing the concept notes, maybe drawing up a white paper and all the things that need to be drafted for the project from the very beginning, so that privacy is included in that design. Then there's also pseudonymization and encryption end-to-end. Okay, I don't think we've touched on pseudonymization. Pseudonymization means, I'm sure many of us are well versed with it, where identity is hidden. So you take on a character. So for instance, in blockchain, the number one pseudo character is Satoshi Nakamoto, because we don't know who he or she or they are. So the character is just known by the name Satoshi Nakamoto. Another form of pseudonymization is the public addresses that we have in the blockchain space. Once you have a public address, for instance, if you go to a wallet like Trust Wallet and you open an account, you're given a public address. That public address is just a set of numbers. No one knows who is behind the numbers, but is it possible to find out who is behind the numbers? Yes, it is. So you're able to, with further information and further details, decode who is behind the character or the numbers or whatever pseudonymous nature it takes. But that pseudonymization at the beginning just hides certain details of the transaction or certain details of exactly what it is that you are trying to hide. And so in some instances, just like I mentioned, some information is replaced by numbers or things like that, so that you are able to retract at the end of the day. But the only disadvantage of pseudonymization is that once the extra details are made available, it's easy to decode who the person is, as opposed to anonymization, which the information is unable to be converted back to status quo. So there are some pseudonymization techniques and encryption techniques that can be used to try and facilitate data privacy on the blockchain. It does depend on the particular project, the kind of data that is involved, the kind of infrastructure that you have decided to use, because there are different types of infrastructure on the blockchain. So it does depend on those details, but those are some solutions that can be explored as a legal counsel on a blockchain project. Then we have what we call ZKPs. ZKPs are zero knowledge proofs. Zero knowledge proofs are a new system and way of providing data privacy. And what this is, I mean, I would have loved to do more slides, but I didn't want to overwhelm us with the information. A zero knowledge proof is having your information placed into a system, and then the person on the other side who you are wanting to reveal the information to, the person doesn't have access to your full information. So let me give an example. Let's say you want to get a job at an organization and you have your digital ID, and your digital ID has your wallet information, all your certificates, conferences attended before, certain personal information, maybe your health information, all of that. And the employer wants to confirm your certificates from OAU, for instance. Both parties can use a zero knowledge proof software that allows the company to be able to verify your certificate without viewing all of the information that is attached to your digital ID. And so ZK proofs are very important going forward because many countries, governments are going to create digital IDs for their citizens. And a lot of information is going to be connected there. So many developers and companies are bringing out what we call these zero knowledge proof software that enable a verifier to verify without viewing all the person's personal information. So the employer enters into the system. I'd like to verify maybe Bookie's certificate with OAU. And once they enter that information into the zero knowledge proof software, the zero knowledge proof software asks for my ID. The employer types in the ID in there. And once my ID is typed in there, that particular software is able to view my information and only selectively retrieve my certificates for the employers to view. They're not able to view anything else. So it's specific information that is viewed via the zero knowledge proof software. So it could be they want to verify my health in a particular circumstance, something that employers can access, and then my certificate and a few other information, but everything else is completely hidden from the employee. So this helps data privacy, especially on the blockchain, because even though this information has been placed on the blockchain, it now allows proofing and verifying of only specific information that the person has access to. This also works for governments as well. So when a government has either legitimate interest or some sort of other reason to check for information, they enter it into this zero knowledge proof, and all the information that they need is actually spit out to them, and they are able to verify that information. So that's how ZK proofs work. There are so many different types. It also depends on the blockchain it is being built on, and we can read more about that, later, but that's how it works. And so that we can see is a solution on the blockchain. And then we also have privacy coins. Privacy coins is something that governments are not too enthusiastic about, because it allows people to spend coins and for those coins not to be traceable. But there are ways of, we always say that in technology, once you are creating something and bad actors are creating a way of retracting the steps, governments too and other industry players are also recreating. So it's a constant recreation process. So privacy coins allow you to spend coins. There's some that have mixers where people are not able to trace where the coins are coming from or where the coins are going to. There are also processes for verifying such. There's blockchain analytics now. There's a lot of forensics on the blockchain that is able to track coins, even though they've gone through mixers. It's just a lot more work, but is actually possible. And then we also have private smart contracts. So we've talked about smart contracts. Some of the contracts could be public, and some of the contracts could actually be private. So there's certain spaces for that. And there's a lot more solutions on the horizon as we go forward with blockchain. I would also like to give the example of when we say that we have solutions on the horizon, even the legal solutions could be in form of technology. So I'll give an instance of the case, the New York case, where the papers were served to the pseudonymous characters. So all they had was the wallet addresses of a system was hacked, and all they had was wallet addresses of those that received the funds and the digital assets from the hack. And so what they did was they took the users to court using their pseudonymous names. And what the court did was that in order to be able to serve the papers to the defendants, what they did was to serve the papers by NFT to the location address. So, and they did it in such a way that once the NFT is opened, they're able to tell via technology and blockchain analytics that this paper has been served on this recipient. So many of the solutions, be it data privacy, be it legal, many of it could actually be lawyers who are, creating, because they have that knowledge of how the law works and how regulation should work. And because they have that understanding of the blockchain, then they are now able to create methods to counter some of these or to aid the legal work at the end of the day. So that's a challenge for some of us, who are well-versed or who become well-versed in the blockchain, to be able to create some of these solutions. You can do that in liaison with developers and all that. So I think that's all that I have for today. I think we can go into questions. I hope, yes, we have enough time for questions. I'll just go into the questions from this point. Thank you.
Thanks a lot, Buki, for the very brilliant presentation. I don't know, did you have a stint at teaching or lecturing before or at any point in your life? Because this was really well delivered and very thoroughly prepared. Thank you very much. I'll say a proper thank you at the end, but in the meantime, let's go to questions. And I thought I saw Davidson here earlier on. I was going to take his comments, but I think he's gone off to make money or something, but we'll see. So, and the first question says, good afternoon. Do we get any certificate for attending the webinar? Thank you. Buki, that's not for you. The answer is yes, you will get. Please, I can't see what she's doing. I can only see her slide. That's fine. I came in too late. We couldn't have done anything with that. I can't see your screen. The illustration you gave didn't appear on my screen. Goodness. Can't see her present screen. I'll see everything clearly, but it appears that people had a bit of a difficulty. Can we have the slides? Yes, you will have the slides on Tuesday, immediately after the last session. I can't view the screen. Please, ma'am, we're not seeing what you're doing. It's just showing the first. So I think what we will do to resolve this would be to send I mean, anybody who has participated can go on MBA ICLE YouTube channel just to look at the video again, and we'll try and circulate the videos independently because it was quite clear from where I sat. Well, we'll see. So thank you, ma'am, for the explanation. You made mention of Satoshi and Bitcoin when you were talking about the hash and others. Please, can you throw more light on Satoshi? I have been struggling to understand the way forward for months now after they stopped the mining. Thank you, ma'am.
Well, so I'm not sure why he or she is asking about mining, but Satoshi created Bitcoin. So in 2008, Satoshi released a Bitcoin, a white paper titled Bitcoin Peer-to-Peer Electronic Cash System. And that introduced Bitcoin, which was to come to become this digital currency and a peer-to-peer transaction. What it did was to remove the middle party. And so people are now able to send transactions to each other all over the world. We know that the way it normally works with traditional finance is that you have to send your money, you send the money by a bank using the messaging and the SWIFT system to send, transfer the money to the bank of the person you are sending to. And so it's an entire process. And sometimes settlement does take a while before it is actually settled. But what this did and what it brought about was that within 10 minutes, I could send money from here to somebody in Turkey and the person would receive it instantly. And I wouldn't need any bank. I wouldn't pay, well, you actually pay something, but the fees are very, very little. So that, was to encourage trade with people globally without the use of banks. Now, when you talk about stopped mining, I'm not sure what you mean by that, but we still have miners going on. I know Davidson mentioned yesterday that the maximum for Bitcoin is 21 million Bitcoin. So once it gets to 21 million, that is when mining will stop. But for now, mining is still ongoing. And the mathematical algorithms and equations become more difficult as the Bitcoin becomes more. So right now, for those who want to mine, previously at the beginning when Bitcoin started, you could use a laptop very easily to mine Bitcoin. But nowadays, you will need to have more sophisticated GPUs to be able to do that right now. So that's still ongoing.
Okay, then there's other question from Adebola Akinsumlola says, can this be used in the area of data privacy?
I think that was asked before we went into data privacy. So
okay.
Now that we have talked about data privacy, we see that the network itself, blockchain technology, can also be used to create software and apps that can help with data privacy. And I gave a few examples of that, like ZK proofs and privacy coins and private smart contracts, which are restricted. Like the private smart contracts are restricted to only certain parties who are able to view and the transaction takes place. So there's some other solutions as well, but that is also possible on the blockchain for data privacy.
So it says, Esther Arinzechukwu says, thank you, Ma. My question is based on immutability characteristics of blockchain. I understand that it has an advantage, but does it have a huge disadvantage? Also, can it be a clog in the development and flexibility of blockchain technology to users?
I think we also treated this as well. The immutability is an advantage. However, for the data privacy laws, which we mentioned, like the right to erasure, right to portability, it does pose a challenge, which is why we now have many people who are building in the space, who are building software that allows you to be able to use the blockchain, but for certain user data. personal data, sensitive data, you would need to have a system in place so that that data is not stored directly on the blockchain, especially when it involves children, people, maybe illiterate people or people of certain mental capacity. Those kind of information, you cannot just store it on the blockchain. So you would need to work with your developers and those in your project to design a method for either storing the pseudonymous hash of that information on the blockchain, or having the entire information stored off-chain, but with a link on-chain, so that those that have access control can access that information, so that you are able to delete it basically when it's off-chain. So that's the challenge which the organizations are still trying to balance right now. But that's the reason why you learn about it, so that you can also help your clients or your organizations be able to maneuver around that.
The next question is from Mustafa Al-Hajibila. His question is, assuming there is dispute, which court may have jurisdiction to entertain the matter?
Okay, so this is a very interesting part. So we actually have decentralized courts. Many people are not aware about them, but they're becoming more popular. They're becoming mainstream in Europe and other places like that. But let me give you an example. If I'm in Nigeria and I entered into a transaction on one of the, maybe like the DeFi platform. DeFi is decentralized finance. And maybe because the DeFi is like traditional banking systems, but they're on the blockchain. So decentralized finance. So if I have a DeFi organization I dealt with and a dispute arises, what would happen is we would take the matter to a decentralized court. So the decentralized courts act as forms of arbitration. And the way this would work is, in your smart contract, there would have been a section that would have selected the dispute resolution method. So once the dispute resolution method is selected and specified in your terms and conditions of your smart contract, once a dispute arises, then you know that this is the place that we have selected. So automatically you go to the decentralized platform to have your matter solved. So some decentralized platforms are extremely sophisticated, where some of them have they have proper qualified arbitrators. Some of them have jurors who are selected just the same way people select jurors in a regular court. In the US, for example, they have jurors who are randomly selected and brought together to hear the matter. They also have systems in place where once the matter is heard and the judgment is given and you are not satisfied with the judgment, you can actually file an appeal. And the appeal goes to the higher ranking court in that decentralized platform. And just the same way we have our systems of magistrate, high courts, court of appeal, and Supreme Court, they also have their hierarchy of courts. And then once you get to the final arbiter, the verdict is final from that point onwards. So we find that because there are many disputes that are taking place globally, and you have this space where countries are still governments are still trying to grapple with some of these technological movement. They haven't really gotten to that aspect. So you find that the decentralized courts are taking their place with such. And then you also have parts of the decentralized courts that have specifically lawyers only who are part of the process and hear the matters and are involved in the matters. So that's just an example of how disputes are being solved in the decentralized space.
Okay, so this other one is from Emmanuel Ewere, and I think you've touched on it, but where there is a breach of contract terms of a smart contract, how can amendment be done?
Yes, so once there's a breach, you would have to go to probably dispute resolution, or if the parties both agree, a new smart contract is then created with new terms, and then you go with the new smart contract. That's where, maybe in the previous contract, the terms are specified, which is the reason why many organizations now try to create the smart contracts without including lawyers. You will still need lawyers. Lawyers are still needed to review the terms and conditions that go into the smart contract. So a lot of people make mistakes where their smart contracts are just basic things they lift online. They just put things together and have a smart contract, but then disputes arise. So that's why we always advise clients, even lawyers who are going into the space, make sure that you are part and parcel of that smart contract process. You review all the terms and make sure that the developers, because, well, in case you don't know how to code, some you know how to code, but you really don't need to know how to code. As long as you're there to advise, they will impute the necessary codes and terms into the code. So that actually does solve it to an extent.
Interesting. So with the we have Omoruddin Yusuf says your presentation is superb. Please, I really need more clarification on invalidity of changing a signed document. Does it include printing out a signed document? Will it be invalidated?
Invalidation of changing a signed document. Once you've signed a document, you've signed it. You really, you could print for your records, which most firms do. Once you sign something, document, a contract of any sort, you still have to print, so you have a physical copy of the contract. But the validity of the contract does not come via the printing. The validity comes via the signing of the contract. Once you have signed it, both parties have reviewed, both parties have agreed, and each party has imputed their signature, the contract is valid. So we find that you necessarily, especially in the blockchain space, you necessarily do not need to print. And for instance, maybe if you buy an NFT and there's an attached agreement and you have signed that agreement and it's saved on the blockchain, what people do is they use file storage services on the blockchain so that file is saved for their records in case they need it later. But for many firms, many lawyers, we are traditional in our approach, and we still want to have that document still, printed out so that we can have, in case anything. It's the blockchain, but you still have to be extremely careful in case anything happens and you don't have a copy of it. So you can then print to have access to that later on. I think there was a question, Miss, which says,
I've seen it. I saw it. Yeah, that's Omolala Baba. But then again, on the last answer that you gave, I think is something that would worry many lawyers, not on this one, but the previous one about the smart contracts and people wanting to circumvent the use of a lawyer. It must be a big worry because everybody's trying to avoid engaging lawyers and paying them fees. So the more enlightenment we also help give, the better. So with the anonymity element / factor of blockchain technology, how does the practitioner track the client's interest?
Well, that's the issue with the anonymity element. Whether your client is anonymous or not, once a project comes to you, you should make sure that all terms and conditions or anything that the client is signing is done properly. And then the blockchain is not anonymous, is more pseudonymous. Okay, so anonymous would mean you're not able to track back to determine who the person is. No, that's not the case with the blockchain. It's pseudonymous, meaning, for instance, let me give an example. If a public address bought a very popular NFT and nobody claimed ownership of that NFT, you might not know who the owner is. But if a public person comes out and says he owns an NFT, or he puts that NFT as his status or any of his pages, people then know what his public address is. And once they know what his public address is, they're able to search that public address and then now track back on transactions. So it's pseudonymous, but it's not like nobody can ever know who that is. For regulatory authorities, the police, EFCC, and all of them, a lot of them have received training to be able to be well versed in forensics and blockchain analytics. So they're really able to track transactions. So it's not like it's an anonymous thing. No, it is not. So you just need to be very careful when you have clients who are within the space. Just focus on all smart contracts that being involved in. If it's a specific project and the client is the one bringing the project to bar, just like any technical project, you just make sure that all the compliance mechanisms are in place, all your KYC, AML, CFT, everything is on point. So you just make sure that compliance and governance on all things that have to do with your clients on the blockchain is extremely, all your I's are dotted, your T's are crossed. So that's what you need to concern yourself mostly about, as opposed to that. So there's no anonymity on the blockchain.
So I have another one from an anonymous attendee. Is there a difference between digital and electronic signatures?
Now, this is part of the contention where they say that all digital signatures are electronic. So because we've read some arguments to say, no, digital signatures are not electronic and all of that. As far as it takes place on a system, it will be categorized under electronic signatures. However, there are now different types of electronic signatures, which is where more digital signatures will fall under. So that's quite a good question. And there's some, the jury is still out there on some of those arguments. But generally speaking, digital signatures are electronic, mostly electronic signatures.
The next is Adioye Kujembola. How do we resolve the principle of non-ex factum with electronic signatures via blockchain?
That is quite tricky, but many of the signing that is taking place is actually taking place just the same way as Web2 signatures. The only difference is the Web3 element that comes into place is that it's being stored in an immutable fashion. So that's the only difference with what we have now. So it really almost is the same dynamics that come to play, which is the reason why many people still prefer for their information to be done off-chain as opposed to be done on-chain, because people just have this certain notion of if I have my signature on-chain, it makes it different or it makes it permanent. It's still the same rules still apply, except for that immutable element where you just say once you don't want something stored permanently on the blockchain, then don't transact on the blockchain. And the blockchain really is mostly smart contracts that are embedded in the code that are executing the transaction. So many people in the decentralized space are trying to remove that human element or that third-party element. That's what they're trying to remove from the decentralized space. And we are still trying to say no, even though it's decentralized, we still need regulation, we still need proper processes and traditional rules come to play. So that's just still what it is.
So another anonymous attendee, are the terms and conditions for the smart contract converted to algorithms? If so, how does a regular lawyer that has no clue about coding do that? And if no algorithm is required, how are the terms practically translated to the block for smart contracts?
That's actually very interesting. Well, as I feel that as a lawyer, you don't need to know how to code. As far as you're working with developers and they understand what you are trying to get across and you understand the system, then I think there's no problem about that. With the introduction of AI, I think that complicates it slightly because with AI, there will be algorithms involved in that processing. Um, so it's still early days. I don't know where it is going because we know that we're still in the regular phase of AI. We haven't even gotten to the general AI phase where AI is being controlled on its own and moving on its own pace. When we get to that point, I really don't know what will happen. But for now, I just advise work with your developers, ensure that the terms and conditions are placed in there. If there are algorithms that are being converted, it's just if and then. If this and then that will happen. So there's not much room for the algorithm to play. The only thing that could happen that I know that has happened previously is if there is a gap or a bug in your smart contract, bad actors could take control of that smart contract and actually maybe siphon the funds. For instance, like if the fund is supposed to go to Uber after the smart contract has kicked in, a bad actor could actually go in there and steal the funds, which is why under smart contracts, there's also a process for testing and finding out vulnerabilities in the system. So as a lawyer who is on a blockchain project, you need to make sure that your smart contracts are audited, the smart contracts are tested, and then vulnerabilities of that particular smart contracts are also tested and verified. Because, like we know, we are dealing with technology, and many things could go wrong. But usually, if you have all your smart contracts audited, the chances are less for errors. So that's what I would say with that in particular one.
We have 4 minutes to go and quite a number of questions still. So let's see what we can ram off quickly before we finish. Thanks for the training. You mentioned the ability to track anyone who accesses information on the blockchain. I'm interested in knowing if it is possible for a person who does not want to be tracked to mask or disguise their identity.
Yes, this is actually possible, and there's a lot of issue about that. I still watched the session with the subcommittee in the US yesterday, where they were talking about cyber crimes. We have what we call mixers on the blockchain. So mixers are able to scramble networks and transactions, so that once a transaction goes into the mixer, it just scrambles it with other transactions and brings it out on another end. So there are actually a couple of systems that are out there that are able to mask and disguise identity. That's why privacy coins come to play, mixers come to play, and that is what regulators are trying to reduce. They are trying to reduce mixers and privacy software that scramble or mask identity. So there are a number of them out there. Yes, I know Tornado Cash, the US went after them because they were scrambling some of their transactions. So they're out there and they are available for those that want to mask their identity. But we'll see how regulation comes to play with that. We don't know if they will place a ban on them or reduce the amount. But the reason why people have their identity masked is because bad actors are actually tracking some certain individuals on the blockchain, especially the more popular ones. So those who are celebrities, those who are known and influencers in the space, once they know their public addresses, they're actually following them and tracking their accounts. So that's the reason why some legitimately use the masking systems, while some obviously as bad actors are actually using it to get away with crime. But we'll see how it pans out. It's still early days. They're still trying to resolve that.
So it's just a minute to 4 o'clock, and I don't know how your time is structured, Bookie. Are you happy to take more questions? I think we've stretched you enough on the questions.
I think I
right?
can take
So one or two more. Anyway, I'll make you smile by what Zimani Iwariso said. Says some lawyers are doing massive things. I can't believe that the two persons that took the trainings are lawyers. Whoa. So just to tell you, people don't believe you're a lawyer. This is what is back end.
Back end is anything that takes place. So front end is what is front facing that the customer or the user can see. So if you go to your banking app, everything that is you can see is front end because that's what they put for your use for the user. Everything else that takes place, the movement of the cash, the messaging that is being sent, all of that is taking place back end. So that's the hidden things that take place to make the front end work.
So for smart contracts, does it mean I must have a written code for every and each transaction? Example, land agreements.
Yes. So each transaction will need to have its own smart contract. But then the thing is, obviously, just the way we have our generic agreements that you just tweak here and there you just make it, you just customize it for each client. So there are certain smart contracts that the base of the skeletal framework of the smart contract is the same. You're just basically tweaking it to customize it for the specific user or clients. So, the developers know how to do all those things. And truly, by the time you work on a few projects with a few developers here, and then you yourself will get the hang of a lot of it without necessarily buckling down to study smart contracts.
So this will be the last question. There are many unresolved cases of the stolen digital assets. Why are digital assets very difficult to trace? Blockchain ought to be transparent, immutable, and secure.
Well, the thing is, we don't have enough trained personnel, unfortunately. We just don't. We need a lot of people in the industry. There are not enough people to track. There are not enough people trained in forensics. There are not enough people. The truth is, each transaction is traceable on the blockchain. There's blockchain analytics. Once it's happened on the blockchain, it is a traceable transaction. But then if you ask yourself, how many people, for example, if I want to ask how many people are working for the Nigerian government on the blockchain for crime, I'm not sure there are many. So that's where the issue is. Even in the US, there are not that many. I know they cut down on some budgeting for people that were working with FinCEN and CFTC, and they had to reduce the number of staff that were working there. So the truth is the industry does not have enough personnel and enough talent. And the talent that is available is very busy. So if you have talent in Nigeria, they're probably working on, the projects that I work on, the developers that are there, they're working on like 2-3 projects, as in 3 companies at the same time, one in Canada, one in Cameroon, one in Nigeria, so they're spread thin. So how many people are going to actually be tracking these transactions? We just don't have the capacity. And that's where we need to build. And if we can build capacity, train people, educate them, and they're aware of all of these aspects that are needed, then we will now be able to begin to scratch the surface with bad actors. But right now, the bad actors, I think, might be having a bit more of a field day. We need more people. So that's it.
Thank you. Wow, Bookie, thank you for that wonderful presentation. But before you go and before I make my closing remarks, I can see that Davidson is right back on. Davidson, I don't know how much of the session you followed, but I would like to get your take on the presentation generally. And are there any comments you would like to make regarding same?
Thank you, Honorable Chair, and good afternoon, Bookie. It's always a delight hearing you. I think it was an amazing presentation. It does build on the introductory session that we had yesterday. I'm sure that for participants who have been following, their knowledge is gradually beginning to build. The weekend presents a wonderful opportunity for people to digest what they've learned and then come back on Monday and Tuesday to get the remaining part of this entire session. But I think it was a really, really amazing presentation. I have nothing to add. Buki is always a delight to listen to, and I'm looking forward to the knowledge that will continue to be spread as this session continues. Thank you, sir.
Thank you very much, Davidson. Thank you for yesterday's session. Thank you for showing up again today and for the support that you've given to Buki and to all of us here. So, but now just to close, I just want to say a big thank you to Buki for today's presentation, which I think was excellent. The presentation was actually amazing and very easy to follow. Interesting to see that we have over 81 questions. That shows the level of excitement and interest and enthusiasm generally, and the fact that people actually listened and followed and are engaged. So thank you very much, Buki, for a fantastic job. To the delegates, I'll just say thank you for attending. And I also want you all to thank Buki and to thank Davidson and the rest of the faculty for what they do. It's giving back. If you are to pay for some of these trainings, I'm sure you know how much it will cost, but for very busy people to give up their time to give back to their profession is really an amazing thing. And I think it's a uniquely Nigerian thing. So we're very excited about it. And it's a huge positive. So on your behalf, I say a big thank you to Buki and to Davidson. And I hope that we'll start building a community of people who are interested in tech and blockchain and all. So thank you very much, Buki. God bless you. We're back again on Monday and Tuesday. And for those who are inquiring about the slides will be made available immediately after the training. We're actually working on a repository where we'll have all the lecture materials taught so people can access them at any time. For those who want to go back and watch, who complain about not following or seeing things, well, we have the MBA ICLE YouTube channel, MBA ICLE YouTube channel. So you can go back and look at the video again. It's already there as we speak. So thank you very much, everybody, for showing up. God bless you all. And I'll see those who show up on Monday. Bye-bye.
Bye-bye.
Thank you, Buki. Bye.
Yes.